So what I'm going to do is I really wanted to hit on 4 key points today. I thought there were really great presentations from all the different companies. So a lot of the information at a background level has already been covered. What I wanted to focus on was benefits of 6 gigahertz. What are some of the trade-offs that come naturally with the propagation and the frequency? How do we mitigate those? And as you know, we've been sampling products. I'll talk a little bit about products and how we can deploy them. And really the last thing I'll touch on is the scenarios. If we just take a look at where we've come, right? Many of us have been in the industry for, I think one of your presenters said very well, many of us have been around for a while, 20 years or so. We've seen a lot of changes. If you just take a look at a couple generations ago and getting close to 10 gig, what does it mean to the average user? I mean, the average user, what they care about is from a download standpoint, what might have taken me an hour not too long ago, I can now get in a couple seconds or a few seconds. And I think that's the value we're seeing as people work more remote in today's environment, or just maybe this might become a trend going forward. How do they take advantage of better connectivity? I mean, I think we've all been on Zoom calls or WebExes when one of the presenters' video gets jittery or the presentation's not clear. I think one thing that 6 gigahertz brings in addition to the bandwidth is the ease on congestion. So I'll touch on some of those points as well. If we just take a look at what is the most important thing, we had a great day yesterday with the US on 1.2 gigahertz of spectrum. I think all of us are waiting for Europe as well. When does that become available? Because I think just across the different markets, there's a lot of opportunity in terms of the new channels that are available in itself. And if we just take a look at what that translates into, from a benefit standpoint, it's very straightforward. We already had OFDMA multi-user MIMO advantage. 6 gigahertz is going to get more of a benefit on top of that. You have more than twice the spectrum as before. You had 80 megahertz channels and 2 160 megahertz channels. We are in the purpose of reuse. And as we get to 6 gigahertz, even though we're all talking about the 7 additional 160, with 80 megahertz, they do get a lot more channels that just increase the performance in the enterprise as well. So this spectrum increase is not just residential, it's enterprise. I think it's going to be IoT from a low latency standpoint as well as automotive. And part of the advantage is congestion. The fact that a decision was made that we're not going backwards to all legacy clients being supported, it will be Wi-Fi 6 clients. I think that actually opens up new opportunities from a performance standpoint as well. You have less contention, you have more free channels. This just takes off gaming, IoT, if it's telemedicine, and probably like Ajit indicated, many applications that people haven't dreamed up yet that will be coming out in the next few years as well. Now, these are the benefits. There are some trade-offs that we have to deal with also. If you take a look at the fact, we do have 760 megahertz channels versus the 2 in 5, but there is a higher path loss versus 5 gigahertz. You have a transit power, if you say, is very close to 250, but what does that really mean in terms of propagation loss? If you go through one brick concrete wall, 10 dB versus 11, not too bad. But through 4 dry walls, as in the US typical home, 16 dB versus 20. So you do have, close to a 6.4 of extra loss as you get the benefits of more spectrum and also more channels. But there's ways to mitigate that. And I think as we start deploying products, the opportunity that's there for us is you can go with higher order of MIMO. You can leverage mesh even more to compensate for that extra path loss. And I'll talk a little bit about those in terms of the different use cases that are available to us. Now, if you take a look at this chart, it's very simply just showing a few things. You could have, for example, on the left, a modem or a gateway coming in, and you could use 6 gigahertz as backhaul to replace Ethernet cable or perhaps MoCA. That is a use case that might actually proceed even before the clients are majority 6 gigahertz. You can have tri-band designs or adaptive designs that I'll touch upon that can handle 5, 2.4, and 6 gigahertz clients simultaneously. You can have mesh backhaul. Many of us are already used to mesh pods in our home, but with 6 gigahertz and the fact that more channels with a much wider backhaul of 160, even in apartment buildings, there's less contention with the neighbor, improving the overall network performance. And all this is in addition to the next smartphone flagship launching. You can actually start deploying these products as early as end of 2020 from a standpoint. There's a lot of opportunities. If you have that modem separated, what else can you simplify in the home? So a lot of opportunities, not only I'm sure from the cable operators, but the telcos, the enterprise guys, as these products start coming out into the market. What this shows you are some of the products that we are sampling today. At a very high level, we started demonstrating this towards the end of last year, and really at CES in January in terms of provisional license in 6 gigahertz. But there's 3 main product approaches we're taking. This is at the product level. At the application level, these can be used in different segments of the market. But just taking it to a practical look at the top left, when we say adaptive MIMO, one of the things that Quantenna as part of ON has been leading on was being first by 8x8 MIMO order to the market with 11AC. What we are looking at now is how do you break that 8x8 into 2 4x4s at a very simple level. The user does not need to worry about it. And since the user doesn't need to worry about it, anyone who's concerned about CapEx budgets and wants to start deploying 6 gigahertz this year or early next year, so they don't have to do another refresh in the next 18 months, they can rest assured that their product is protected. In the sense, if you do not have 6 gigahertz clients, the device can very simply act 8x8 MIMO for 5 and 4x4 for 2.4. However, if there are 6 gigahertz clients, the device can dynamically adjust itself to support 4x4 5, 4x4 6, or you could also use 4x4 for backhaul. Also, if we talk about some of the trade-offs on 6 gigahertz and the propagation characteristics, if, for example, the 6 gigahertz client was further away from the access point or the mesh node, you can, as an AP, decide to revert back to 5x5 and pick it up that way. So you get to enjoy a few things. You can deploy a product knowing that it's going to be feasible and practical a couple years out from now. You don't have to redo that CapEx. But at the same time, the product is intelligent enough to help decide should it be going from the 6 to an 8x8, 5x5 MIMO order to support that. And then, of course, you can extend that to a very straightforward vanilla tri-band solution where you have a dedicated 4x4 for 5 and a 4x4 for 6 and a 4x4 of 2.4, which builds on our 11AC architecture right now. And then the last product, of course, is with 6 gigahertz, there's a lot of value in terms of mesh. You can have a mainstream mesh node that would be a 8-stream product, 4x4 in 5 or 6, and then 2x2 in 2.4. So, products that are sampling today that can be deployed in 2020 or early 21, depending on customers' product cycles, and have different price points and tiers in the market. Now, if you take a look at what are some of the considerations as you deploy these products. Now, from a silicon standpoint, we have, I think one of the other presenters mentioned this, we start working on stuff like this, at least 12 to 18 months in advance. And I'm sure many of us and our companies are already focused on Wi-Fi 7 with 11BE. And I think a couple of the device companies mentioned that from a architecture standpoint. It will take time to have the majority of the clients in anyone's network be 6 gigahertz. I mean, there's just a large installed base of clients today. And what we've seen with previous generations is even with multi-user MIMO clients, it did take 2 to 3 years for the crossover to be a point where the majority of the clients were of that standard. So with our adaptive architecture, our goal is to make that decision easier for the customers that they know that the technology product they ship can dynamically support both, and they're not wasting that extra MIMO order till the majority of the clients are 6. So that's one strategy to accelerate the market. The other, of course, is you deploy flexible solutions from 6 that take advantage of the market today. One, of course, is mesh backhaul. There's a lot of value in that. Even with the propagation characteristics, how many mesh nodes you have do give a lot of backhaul. And given the fact that you have more channels, there's less contention with your neighbor. And adaptive MIMO maximizes your investment from day one. The other thing that our engineering team works very closely with our customers is the smart channel management band steering, which is especially even more important as you introduce that 6 gigahertz tri-band. And then, of course, reducing the risk by working very closely with the different component suppliers, both on radio and front-end technologies. And from our standpoint, like I indicated, Klaus, we started sampling this to our customers already. I'll be happy to take questions.
Yeah, great, excellent presentation. I'm happy we're getting down to the nitty-gritty of actually how to basically configure products starting now for the new 6 gigahertz band. And I think you've covered that point really, really well. I mean, perhaps, and agree with me or not, perhaps one of the first applications of 6 gigahertz will really be what one speaker has called a bookended application. So two things really: a form of backhaul connected to other devices that perhaps are not in and of themselves running 6 gigahertz, and mesh, where the mesh backhaul itself could run 6 gigahertz. Do you agree with that?
I do think it is a very practical approach because one, you are reducing your dependency on the clients to be available, and you still have a very valid application that plays to 6 gigahertz strengths, but at the same time also allows you to deploy to an advantage. So I think mesh definitely will be one of the early launch products of 6 gigahertz, but also if you can use it to replace an Ethernet cable or something for a very dedicated solution. And I think, I think that would be a valid application in the early days as well.
And you have new products out, which has to do with this adaptive concept where you can reconfigure or configure parts of your chipset to 5 or 6 gigahertz as according to a intelligent adjustment scheme of some sort. Can you maybe comment on what such a scheme might look like? I mean, what would trigger the reconfiguration, for example?
Sure. Definitely. So a couple points. There's different aspects to it, as you can imagine. Some of course, is algorithms and software, and other, of course, will be your hardware configuration. So without going into, it's patent pending from our standpoint, so I can't go into all the details. But at a very high level, on the hardware side, what we do is with our RF architecture, we support across the 5.7 from a frequency standpoint. Which allows us a flexibility of our MAC architecture. However, the real heavy lifting is from a software standpoint. How do you decide as to when do you dynamically adjust? Now, it is not instantaneous, and it's definitely not at a packet-by-packet basis. But we're talking more at the order of minutes versus a longer time frame. So it's very flexible from that standpoint.
Right, and this is part of the ON solution, or you have partners that are working with you to develop this, or
no, this is part. Well, it is part of the ON solution. The baseline offering is ours, but of course, like other people in the industry, we work with a lot of ecosystem vendors on the FEM side and all that to make it real. So definitely, a lot of strong partners in that space.